Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating blog post about optimizing a Sudoku-like puzzle solution. The author, incredibly, managed to reduce the solution time from hours to a mere 360 milliseconds. Amazing!
Whoa, 360 milliseconds? That's insane. What kind of optimizations were involved? Was it just a matter of using a faster algorithm or something more profound?
It was a multi-pronged approach, a real tour de force of optimization. It started with a naive attempt using Z3, a powerful SMT solver. Unfortunately, that took hours and didn't even finish.
So they went back to the drawing board? What was the next step?
Exactly. They realized they could leverage some mathematical properties of the puzzle. The key insight was focusing on the greatest common divisor, GCD, of the numbers formed by each row. This GCD, let's call it X, had to be a relatively small number, which significantly constrained the search space.
I see. So instead of a completely blind search, they had a much more targeted approach. Did they use brute force after that?
Initially, yes, a brute force search using breadth first search, BFS. But even that was slow, taking several minutes. The first improvement was replacing a hash set in their is_good function, which checks if a number has 9 unique digits, with a bit set. A huge speed up right there.
A bit set is a clever choice. Much more memory efficient. But even with that, it was still too slow, right?
Right. The next level of optimization involved SIMD. Single instruction, multiple data. Instead of processing one number at a time, they processed multiple numbers simultaneously using SIMD instructions. A significant leap forward.
Impressive. But they didn't stop there, did they?
Nope. They further refined their SIMD approach by creating a function, isGoodMany, that checks multiple numbers concurrently. This reduced the overhead of repeatedly calling the SIMD function. And finally, they addressed thread contention by having each thread work on a larger chunk of numbers at once, reducing the need for constant synchronization.
So it was a combination of algorithmic improvements, data structure optimization, and clever use of parallel processing. Fascinating.
Precisely. And the final result? A mind-boggling 360 millisecond solution on a 16-thread machine, a speed-up factor of over 1,600 times compared to the initial brute force approach.
Incredible. But there's a funny twist at the end, isn't there?
Oh, yes. The author points out that all this optimization was, in a way, unnecessary. Simply hard-coding the answer would have been infinitely faster. But the journey of optimization itself is what makes this blog post so compelling. It shows how much performance can be squeezed out of seemingly simple problems.
It's a great example of the power of optimization and the importance of understanding the underlying algorithms and data structures. A truly inspiring read.
Absolutely. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.